Hi everybody, welcome to the first video in statistics. On this chapter 1, there will be a lot of reading and I will not read everything that is in the note. I'll just go over some important things. First, we define what is statistics. It is a science of collecting, organizing, summarizing, and analyzing information. So information referred to as data. And so on this chapter 1, section 1.1, it is important to distinguish the type of the data. I'll go over that in more details later, but first, population and sample and parameter and statistic. So the entire group of individuals to be studied is called a population. So we have the population is the whole group of individuals. An individual is a person or an object that is a member of population. So population we have the whole thing. As opposed to a sample, it's a subset of the population. So population is the whole thing, and a sample is a subset of the population. So for example, if we talk about the whole population of the world, that would be the population, and the sample will be a subset of it. Maybe we select 10 random people in that population and we call that a sample. Right. And next, a parameter is the numerical summary of the population. So the population will be a parameter of a population, where statistic is on a sample. So the population will be the whole thing, and there will be a sample inside of the population. And the population, a number represent a population is parameter. And the number represent the sample is statistic. For example, if we talk about the population of the left-handed people, if we talk about the population of the world, for example, and maybe let's say 11 to 13% are left-handed, or if we talk about the sample of, let's say, everybody in the class, we have 25, with me it will be 26, and the percent of left-handed people, in that case, will be a statistic. The parameter is for the whole population. Right. So here's an example. Suppose the percentage of all students at a college who have a job is 84.9. So this value is the parameter. So if we have all the students, so that's referring to a population, and that number, that values represent a parameter. Now suppose that we have a sample of 250 students, and that is a sample, and the percentage is 86.4, and this one represent a statistic. So statistic is of a sample, a parameter is of the population. Right. Next, branches of statistic, that's descriptive and inferential. The first part of the class we deal with descriptive, and later on at the end of the class we'll study more about inferentials. and the processor statistic. I'll let you read that. Like I said, I will not go over everything here. Variables. So important that in this chapter you need to distinguish the type of the data. Variables. Definition of variables are the characteristics of the individuals within the population. So, for example, for a person could be left-handed, right-handed, age, and other distributed, and all of those are called the variables. Right. So first, we need to distinguish between the qualitative and quantitative variables. So qualitative or categorical variables, so that based on the attribute or characteristic, as opposed to quantitative variables, and this is the numerical measure of the individuals, and these values can be added or subtracted and provide some meaningful results. Right. So we have some example. I didn't see any example here. So example of category. For example, we have the class freshman, sophomore, junior, and senior. Right? Those are category and not numerical values. Or we can have like the month in a year, or the subjects of studies, something that does not have the numerical values, it only have the attribute or characteristic. Quantitative, something that has the values, for example, age, weight, or other attribute that has the values. Something like that. Right, so that's the first distinguish between the variables. Next, we have discrete and continuous. Discrete is a quantitative variable that has either a finite number of possible values or a countable number of possible values. So we have either finite or countable. The term countable means the values from counting such as 0, 1, 2, 3, and so on. A discrete variable cannot take every possible values between any two possible values. Right. So discrete values either finite or countable. So finite, for example, if we say from 0, 1, 2, 3, 4. If we talk about all those 4, that is finite. Even though if this go on forever, that is infinite, but still countable, right? So those are discrete. Even though it doesn't have to be 0, 1, 2, if you have 1 or 1.5, 2, and 2.5, and if you have those values and the halves, those still considered to be discrete. Continuous is opposite to discrete. It has an infinite number of possible values. So when we talk about not between 0 and like that, we talk about anything from 0 to 1 continuously. There will be everything on this number line. So those are considered to be continuous variables. Right. Let's look at this example. Classify each of the following quantitative variable as discrete or continuous. Right. One thing to note that discrete or continuous only for quantitative. Variable. Alright, so let's look at these quantitative variables and determine if it is discrete or continuous. So number of children in your family, well, that have to be discrete because we cannot have half of the children, right? So this is discrete. Daily intake of whole grains measured in grams. Now this is continuous because it can be as small as, any number. We could have like 2.5 or 2.55 or any values. Number of books in a shelf, so that have to be discrete because we cannot have half of the book. And the height of an NBA player, well, the height, even though listed, usually they round it to like to the inches, but in reality you can have half an inch or 3/4 of an inch or even smaller increment. So that is considered to be continuous. Right. So far we have qualitative, the one that go with category, characteristic, attribute. Quantitative, that the one that go with numbers, and the one that go with numbers, quantitative data can be discrete or continuous. Now next, we have the level of measurement of a variable. So this is also the different type to characterize variable. So first, nominal level, the values of a variable name, label, or category. So we talk about like qualitative data. In addition, the naming scheme does not allow for the values of the variable to be arranged, ranked, or specific. For example, if we talk about the subject, physics, math, history, different categories, and none of them are more important than the others, right? Or also the month or the year. Well, that's the different, even though there is the system to rank them, so that the month of the year is not. But the subject is, we cannot rank the subject. So an example of this is the subjects such as math, history, or English. If we cannot rank them, you cannot say something is more important than the other. Right. Ordinal level, it has all the properties of the nominal, but the naming scheme allows for the value to be ranked. So the ordinal, you can order them, so that's rank or in the specific order. So here's some example. I will talk about class rank. Freshman, sophomore, junior, and senior. Even though there's a name category, but we can rank them. Right. Next, interval level. It has all the properties of everything above, but the difference between the values have some meanings. So the interval, there is the differences. The difference here meaning the subtract. It has some meaning. Values of 0 of the interval level measure does not mean the absence of the quantity. Right. For example, if we talk about temperature, if it is between like 10 degrees and 20 degrees, the difference is 20 minus 10 is 10 degrees. Or we can go from 50 degrees to 60 degrees. The difference is also 10 degrees. Right? Now, so the difference have meaning to it. But if we say 0 degree, doesn't mean there's no temperature, right? It's just the temperature is equal to 0 degree, doesn't mean there's no temperature. Right. Arithmetic operations such as addition, subtraction can be performed. So there's addition and subtraction. Or we might talk about age. If a person is 20 years old and another person is 30 years old, the difference is 10 years. Likewise, if we talk about 40 and 50 years old, the difference is also 10 years. We can subtract them, right? However, you can say also that the 40 years old is twice the age of the others. Whereas we talk about temperature, the ratio might not has, we cannot say twice as hot, right? 10 degree and 20 degree, we cannot say 20 degree is twice as hot as the other. However, the age, you can say that. And that brings to the next level is the ratio. So the ratio, first, the 0 has some meaning, mean the absence of the quantity. Arithmetic operations such as multiplication and division, the reason that we can divide them, meaning there's a ratio, and that's why we call that the ratio level, right? So let's go over some examples and see what type of the level it is. So determine the level of measurement for the following variable considers. Right. I see the number of snack or soft drink in vending machine in school. Right. So we might have, now it is not actually talk about the numbers. Talk about the snacks and the drink vending machines. We have this vending machine sell some certain things, this other vending machine sell some other things. Or if we talk about the numbers, by the way, that is this Greek number. Now if we focus on, depends on here, but let's say if we focus on the numbers of snack or the soft drink machine, so that number can be 0, 1, 2, 3 and so on, right? If we have 0, that means there's no vending machine, so the 0 has a meaning. And let's say if we instead we have 5 vending machine and then 10 vending machine, then the 10 will be twice as much as the 5, so the ratio of them has some meaning as well. So because of that, it is called the ratio. The reason meaning 0 means no vending machine, so the 0 has a meaning. And we talk about numbers, so it is not going to be ordinal or the nominal. I should spell it out. 0 means no vending machine, and the difference have some meaning, the ratio have some meanings. So if we have 10 machine, and if we double that, we have 20. That certainly has some meaning. Right. Next, where there or not a school has a closed campus policy during lunch. So the answer is either yes or no, right? And yes or no. So first of all, that qualitative data, and we cannot rank yes has more meaning than no, right? So in that case, this is called a nominal. So the first type is where we cannot rank them. So just nominal. Now, even though on some survey, or usually if we call them in the touch tone, for example, it said if yes, press 1, if 0, press 2, even though there's a number 1 and 2, but those numbers doesn't mean that the yes is more important than the no. Also, the difference 2 minus 1 has no meaning at all. So in that case, and you cannot rank them, so this is nominal. Class rank, we already talked about that. It is category, so qualitative data, but since we can rank them in some certain order, this is called ordinal. Number of days per week a student eats school lunch. So we talk about numbers. Right. So it is either ratio or interval. Right. So the interval, the value 0 doesn't mean the absence of the quantity. So the question is, if the answer is number of days per week a student eats school lunch, so it could be 0, 1, 2, 3, 4, and 5. Let's say only school day. Saturday and Sunday considered weekend, let's say, not at school. Right. So it can be any of those numbers. And the question is, does 0 has any meaning? And the answer, yes. 0 here means a student does not eat lunch at school. Right. And then the ratio. If a student has 1 day versus the student eat 2 days, you can say that twice as much. Right. So because of that, so once again, 0 and ratio has meaning. So this is ratio. Next, the temperature in Fahrenheit of a day in a year. Well, this is, first of all, it is a number, and it is, so it is quantitative, and it is also continuous because it could be any numbers, right? So temperature. Now, my question is, does 0 has a meaning? And the answer is no. So we say 0 degree Fahrenheit does not mean no temperature. And you cannot say 50 degrees and 100 degrees. You cannot say 100 degrees is twice as hot as 50 degrees. Right? So the ratio does not mean anything. There's a difference though. We can say 100 degrees minus 50 degrees is 50 degrees. So the difference is 50 degrees. that is the interval. The difference have some meaning, but 0 does not, and the ratio does not. So because of that, let's call the interval. Next, the mass in kilograms of a rock. Now, my question is, if the mass is equal to 0, 0, we can say that it is no mass, right? And an object that weighs 2 kilograms versus an object that weighs 4 kilograms, you can say the 4 kilogram object is twice as heavy as the other object. So the ratio and 0 has some meaning. So that is a ratio. Because 0 and the ratio have meanings. Next, the colors of M&M. So different colors of an M&M, but you cannot rank the order, right? The order, the colors can be put in the rainbow spectrum or something like that, but we cannot say one is more important than the others. So in that case, it is called nominal. And the type of the medals of an event at the Olympics, well, they're gold, silver, and bronze. There's certainly some order of that, so that is ordinal. So bottom line is, in the first section, you need to determine, you need to know that the type of the variables. First, we characterize quantitative, qualitative, and in the quantitative, that is discrete and continuous. And then we can also classify the variables in 4 levels: nominal, ordinal, interval, and ratio. So the first section, we need to know those things. On the second section, there will be a lot of reading. I will let you do the reading yourself. I don't want to go over this on the video. But in this section, just need to distinguish 2 things: observational studies and a design experiments. So just like the name it, observational studies, so we just observe. And then the design experiment, we have to do something to it. So the first 2 examples, we distinguish the 2 types of it. So the first one is to investigate the cancer risk with the cell phone use. And the study of, they just keep track of these people, and after some years they come back and do and check the result from it. They don't do anything to it. So this is called the observational studies, as opposed to another study about the same thing, about the cell phone use versus the brain brain cancer risk. So we have in this case, we have the rats divided into groups. One group were exposed to the cell phone frequency, and the other one is exposed to the digital. And then after some times, we come back and compose and compare those 2. So that is the design experiment. And other things to it, like I said, I'm not going to read everything in the video lecture here. You need to do the reading yourself. Right. Next, section 1.3, simple random sampling, and section 1.4, other effective sampling method. Right. So we talk about statistics. Statistic is the number of a sample versus the parameter of the whole population. So the goal of statistic is that it would be nice if we can find everybody in the population. That number is much better. But usually the population is too big. We can not only do the study on a small subset of the population. For example, before an election, there's a poll. You cannot ask everybody what they're going to vote for. They can only ask for maybe thousands of people. And then within that sample, they make a prediction of what the population, what the parameter of the population is going to be. So, but in order to have the accurate statistic that will infer the parameter of the population, we have to choose a very well sample. For example, talk about an election again. If you ask 10 people in California and 10 people in Texas, the voting result might be different. What they think about will be different, right? So in that case, we have to choose a sample that well represent the population, right? So in that case, how do we select a sample that is well represent the population? Here are some methods. First, random sampling. Random sampling is the process of using the chance to select individual from the population to be included in the sample. If convenient is used, the results of the survey are meaningless. Like I said, if you want a survey of something, you cannot just go out there and ask the first 10 people you see. You have to have the systematic or kind of method of select people randomly. And a sample of size n, a population of size n through the sample random sample. Right. So here's a convention that we will use later. The population, we use the capital letter. And the sample, we use a lowercase letter. And the thing about the random, simple random sampling is that it has to be equally likely chance of occurring. For example, if you ask somebody, the first person and the second person will have the same chance of being asked. And that is called a simple random sample. Right. So here is a sample. Let's say we study the group consists of 5 students. If a sample, 2 of the students must go to the board to demonstrate a homework problem. So we're going to choose 2 of them out of the population of 5, right? So list all the possible sample of size 2 without replacement. Right. So we're going to choose 2 out of those, and we cannot choose one person to go to the board twice. So that's why it says without replacement, meaning that you cannot choose one person to go to the board twice. So have to choose different people. Right, so we choose 2 is the sample of size 2 versus the population of 5. Right, so how do we do that? Now, it would be a nice if there's a systematic way to do that. So let's say if you choose Bob to be the first person, and then the second person can be one of those, right? So I'm just going to list here. Just use Bob and Patricia, and then Bob and Mike, Bob and Jen, and then Leah. Right? So if you want, Bob is one of those, have to be there. Right, next, you go to the second person, Patricia. Now, if we say Patricia and Bob, we already have that. So we go from here, going to the right. Patricia and Mike, Patricia and Jen, Patricia and Maria. And then next, if Mike has to be there. If we go back, Mike and Bob, we already have that. my Patricia already have that, so we have to go to the right only. My Jane and Mike. This is Mike. Maria. And now we go to Jane. And like I said, we do not go backward, we go forward to the right. And Jane and Maria. So let's say we have, if we want 2 out of 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So 10 different cases. Now, if we want to pick them, we can just put 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 associated to each one of them. And we're going to pick a number randomly. A way to do that in the calculator. Hit math, probability, and we can say random integers. Let's say from 1 to 10. You see, I just pick a number randomly from 1 to 10. And then when we have that, we will look up the combination that we have. So that is the simple random sampling. Right, a step of obtaining a simple random sample. So first we obtain the list of individuals of the population of interest, number them from 1 to n. Use the random number table or graphing calculator statistic software to randomly generate n numbers where n is design sample. Let's see if we can do that here. Alright, so that will randomly select 5 numbers from 1 to 10. Let's do this a few times. Okay. The problem is sometimes the number repeat. In that case, we have to throw that away. Choose something that is not repeating. Right. So once again, math go to probability, randomly select an integer. Right. Next. So the way we do that is we just list them and then we choose a software calculator or a table. Back in the day, the book of random number, by the way, if that is the case, then there's only one random type of numbers. But now we can use a calculator or any software, or if you just talk to your phone, and the phone will pick the random number for you as well. Right, next. In the 112 Congress of the United States, there's 435 members of the House of Representatives. Explain how to conduct a simple random of 5 members to attend a lunch. Alright, in that case, 435, put them in order, alphabetical order, and then we use a calculator. Right. Let's rank them by name, by last name, and then we're going to choose from 1 to 435, and we're going to pick 5 of them. Close it. Right. And then just go to the roster and pick out those numbers. Right. Okay. The answer will vary every time we do this, so I'm not going to write the answer down. It just depends on whatever your calculator gives you the random sample. Alright, so that is what we call the simple random sampling. Next, stratifying sample. Now another effective way is what we study here, stratifying, systematic, and cluster sample. Those are different ways. Right, stratifying sample. A stratified sample is obtained by separating the population into non-overlapping groups called strata, and then obtaining a simple random sample from each stratum. This is the singular form of that. That is the plural form of this. The individual within each stratum should be homogeneous or similar in some way. Right. Here's a sample. Example: in 2008, United States had 47 Republicans, 51 Democrats, and 2 independents. And the president wanted to have the luncheon with 4 Republicans, 4 Democrats, and 1 order was 1 independent. Obtain a stratified sample order to select members. Alright. To obtain this, we will put them in groups, or we will select 4 Republicans from 47 and 4 from 51 Democrats and 1 orders from 100. Okay, so we did not say 1 independent. This is just 1 order. Could be anything. All right. So in that case, we will select 4 from the 47, and then 4 from the 51, and then 1 from 100. But that the thing is, this one can be everything that is not chosen previously. So the thing is about the stratum here will be Republican and Democrat. Right, so they have some common characteristic of that. Right, we will have a few examples of this. Next, systematic sample. A systematic sample is obtained by select every k individual from the population. The first individual select is randomly numbered from 1 to k. Right, so the key of systematic is every k individuals, and the first one from 1 to k. For example, if we talk about the earlier example that we have 10 set or 10 samples like this, and we want to choose one of those. Okay, so systematic sample, actually forget about that. Let's say we have 10 numbers, 10 people. A systematic sample is where we choose every k. So we say, what is k? And my question is, what is the sample size? Right. We'll go back to the 10 here later. Right, let's go to a first example. A quality control engineer wants to obtain a systematic sample, 25 bottles coming up following machine to verify if the machine working properly. Design the sample technique to use to obtain 25 bottles. Alright, so first, when it coming out, and we need 25. The sample 25 depends on how many bottles we have, and then we can divide that from. So that kind of bigger number. Let's go for something easier. So the step is to determine that something with the known size population. So let the population size be the capital N. Determine the sample size N, and then we let K be N divided by N. Alright, so you go back to this example. The population here N is 10. So then 10 individuals from 1 to 10. Now if we want the systematic, let's say the question is the sample of size 2. Let's say if N equal to 2. So we want to pick 2 out of these 10 people, right? So first we're going to find K, and let's say K is equal to big N divided by little n. 10 divided by 2 is 5. So k is going to be 5. So what do? Put that into that. Every 5. And then we're going to choose every k individuals. And we randomly select a number from 1 to k. Let's say from 1 to 5. I'll just use a calculator. Right, let's choose 1 to 5. And if you select one number, we don't have to say pick one number. Alright, we have 4. Right, so we're going to do 4. Now the difference between the stratified and the systematic is that we only select the first thing. And then after that, we every 5 numbers. So we're going to plus 5 to it. And 9. So if there's 5, the set of 5 more people, we're going to pick the 4th one. So pretty much we choose 4 and then plus k, which is 5 every time. So 4, 9, and plus 5 will be 14, and plus 5 will be 19, and then so on. So that is systematic. We only select the first one randomly, but after that we just plus k every time, and k is b n divided by n. Now go back to this example. We don't know the population yet, but let's say if we know the population of 1,000 bottles, right? Let's say for this example, assume that there's 1,000 bottles, and we want the sample size of 25. So we take 1,000 divided by 25. That's 40, meaning we have like block of 40s, and then within that we pick one randomly, and then just plus 40 every time, right? So let's say from 1 to 40, k is n divided by n. Big N is 1,000 divided by little n 25. So k is 40. And then we randomly pick a number from 1 to 40. That's 40. Or if you write that, just hit a few times. And then let's say stop. Okay, 8. Right, so 8 will be the first bottle. And then to plus 40 to it. So we're going to pick 8, 48, 88, and so on. So that is a systematic sample. Right. Next, we have a cluster sample. A cluster sample is obtained by selecting an individual within a random selected collection or group of individuals. So the key here of the cluster sample is we select all individuals. Here's an example. A school administrator wants to obtain a sample of students in order to conduct a survey. So she randomly selects 10 classes and administers the survey to all of those students. So the key here in cluster is that all students in those classes, 10 classes, right? So that is a cluster. By the way, let's say if you want, let's go back to the poll in the election, for example. You cannot say, okay, I would choose 10 people in Texas and just ask them what they're going to vote for. Well, that is not going to well represent the population. But instead, because you cannot just say you choose 5 people at some certain area, it's not going to work. So usually in the poll, the cluster is kind of difficult to do that. However, the survey, because the class, we assume that the class, for each class, the student will kind of distribute it kind of evenly into those classes. So that's why we can pick a cluster like that. Right. And like I said, there will be more samples to that. But here's some picture representation of the type of we do. So simple random. So let's say we have from 1 to 9 people and we just pick 3 randomly. So that is a simple random sample. Next, stratify. We divide into 2 groups. Look like here we divide into a group of male and female, and then we select 2 of each. And when we select 2 of each, that is randomly select 2 out of each group. Next, the systematic. Put them in that. And then we choose every third person is selected. And in the first one, we randomly choose that could be 2, so that every third person will be selected. That's systematic. And the cluster, say we have a set of 24 people here. We divide that into 6 groups, and when we select, we have to use the whole group. So in that case, we choose this first group and the 5th group, and have to do the survey for all those groups. Right. Now, let's look at the first example. A student in an education class is given an assignment to find out how late typical student at his campus stay up to study. So he consider actually it's only 3 here, 3 different methods here. First, stop by the union before his 9 a.m. class and ask everybody sitting at the table how late they were up studying last night. Well, that's kind of good, but if you ask everybody at 9 a.m., kind of specific here. So if everybody there, maybe they sleep early so they can wake up early, those kind of things. So if we have to choose that, so the time should be random here. But the thing here is, the key here is that ask everybody there. So just like we said about cluster, right? If we select everything in some certain group, or we choose a few groups, so that's not very good. That is a cluster sample, cluster sampling. But it would be better if he ask a 9 a.m. class, and then he might go back again, maybe 3 p.m. for example. Actually we should pick 2 random time and ask everybody in those. I think that will be a well representation of the population. But the key word for cluster is everyone or all or everything. Right. Next, ask 50 students at different time and places at campus. So this is just random. So this is called simple random sampling. And this is cluster sampling. Then next, look at the campus directory and choose the first name at the top of each page. Well, so that is systematic, because assuming the page of the book, let's see, some certain page will have kind of the same number of names. Unless the names are too long, they have to break into different lines, for example, something like that. But we assume that each page will have the same number of people, and we choose the first one every time. So this is called the systematic. Sampling. So this section we need to distinguish the type of sampling so that the sample will well represent the population. Right, so determine the type of sampling used. 35 math major, 29 music, and 26 history major. I'll randomly select from those. What sampling technique is that? Well, first of all, we look at the population. We have over 1,000 here, and we select those. Now, we select 35 math out of this, 29 music out of this and 26 out of that. Well, the way we select like that, the key here is we do not select the whole group, so they cannot be cluster. It cannot be systematic because there's no systematic about this. Even though we randomly select, but it is not simple random because we do have them in group, or we should say we have them in stratum. So in that case, this is called stratify sampling, because each group has common characteristic. So stratify sample obtained by separate population in non-overlapping groups, and the individual in the stratum should be homogeneous or similar in some way, so they have some common characteristic. And of course 35 math, they have same characteristic that they're math majors, right? So that's stratified sampling. Next, a local technical school 5 auto repair class are randomly select, and all of the student, because now we see the key word here, right? All of the student in those class are interviewed. So that is called the cluster, which choose the whole everything in that class. Next, the name of 30 employees are written on 30 cards and placed in the back, and we just pick one from the back. What sampling technique was used? Well, and like I said, there's no systematic about this, and there's no cluster, no stratifying. So it is just a simple random sampling. Next, every fifth unknown entering an airport is checked for extra security screening. So the key word here we say every some number, so that have to be systematic. Right. Next, a travel industry research interview all the passengers on the 5 randomly selected crews. What? Okay. Again, we see select 5, and the key is all of the passenger in those crews. So that is called cluster sampling. Right. So this section we need to distinguish the type of the random sampling. So that once again the goal is to have a sample that well represent the population, so that the statistic will be a good estimate for the parameter. Right. Next we have bias in sampling. Right. If the results of the sample are not representative of the population, then there will be a bias. Alright, the sort of bias is sampling bias, non-response bias, and response bias. Right, so we'll just over a few things. Right, sampling bias, we covered this in previous section. If we do not choose a well sample, it will not well represent the population. Alright, that the technique have to be. For example, if you ask who you're going to vote for and you ask 100 people in Texas and 100 people in California, the result will be different. And none of that is a good sample. Right. Under coverage, result in sampling bias, when the proportion of one segment is lower in the sample than it is in the population. For example, the very good example of this is the House representative. Based on the population of the state, they will select California have the most people, so they have like 50 something member of the House Representative. Wyoming or the state that have not have a lot of people, they don't have a lot of members in the House Representative also. So that the way it is. So the House Representative will well represent the population, right? So in that case, we have to choose the sample that will represent the population. So in that case, there will be no bias. Next, non-response bias. Non-response bias exists when individuals select to be in the sample and do not respond to a survey have different opinion than those who do. For example, if you ask, let's say, I'm standing in front of class, I said something that you don't want to, do you like a class or not? Let's say the survey at the end of class. If I stand there and look at everybody in the class, I ask that question. Well, and the answer is either yes, no, or no comment. I probably have a few more no comment because, like I said, for some reason they don't want to tell that directly to my face, something like that. Or let's say if you ask what is, for example, something, let's say what do you think about gun control? Let's say, do you like it or not, or no comment? And let's say if you have like or something like that, or some survey, I'm just going to give back some result here. You say 20% of them say yes, and then 30% no, and then 50% that have no comment, or what we say non-response. Let's say if we want to vote something, and you ask 100 people, and this is the result. Based on this result, you can say that the majority of the people who voted no in the issue. However, what happened? They are about 50%, right? So in that case, even though we say yes, it is true to say that the majority of the people who voted no, so there are more people voted no than yes. So that's also true. But however, does not represent the true meaning. So in that case, the non-response can be improved that you use callback or reward incentive. So in that case, if you want a better result, you have to track down these 50 people and ask them again. And they have to choose either yes or no. In that case, we will have a better picture of this. So we have to choose the good sample, and now we have to choose a good sample, and then the way we design the question, make sure we address this issue of non-response. Now, even though if it is, you still have the response, but still you might not have a good result of it. All right. Now, response bias exists when the answers, even though you have the answer, but the answer might not represent the true feeling of the person who do the survey. For example, if I ask you, have you ever cheated on your exam? Probably I will have the answer no more often than in reality. Or also, if you ask in the group, like misinterpreted answer, how many push-ups can you do in a minute, or the annual salary, usually I want to give a little more. If I ask how many push-ups you can do or a person can do, if you ask me that, I usually tell them a little more than I actually can do it. Or if you go to the account loan and you say what is your salary, so you can do the run the credit and then say what will be the rate. Usually those things, the salary you tend to give a little bit higher than the actual values. So those things could be a problem also. Next, the wording of the question. Do you favor or oppose the reduction of taxes, or do you oppose the reduction of taxes? Those two questions are kind of the same thing, but this answer was yes or no. But the question should be asked is, do you favor or oppose? So you don't have bias in the question itself. Like I said, the answer can say favor or oppose. In that case, you don't kind of have the idea. For example, after a game and an interview, ask the player, for example, you just win the game, how do you feel? Or you just win the game, it must feel good, right? Okay, so those kind of questions, the first one should be better, like I said. Like you should give the favor or oppose instead of that. Now, even though that is still not the best way, is we have the order of the question of the words. Right. So let's say you ask 1,000 people and the question exactly like this. That should be fine because there's only two options here, either favor or oppose. Right? Now, so that's okay. But the best way is you bring out, like I said, 1,000 people, right? 500 forms that say, do you favor in oppose? The other 500 will say, do you oppose or in favor? So kind of switching the option so that you don't have a lazy person who just pick the first option all the time. Okay, so that of course not really the case here when we have only two options here. But if we have more options, then the person do the survey will tend to read only the first one. Right? It's not like multiple choice on the test, you tend to read more options. But in real life, like the survey or something, when there's no right answer, usually they just read the first few if there are too many things here. So let's see, what is the most important problem facing American youth today? And if I give some option like that, if I give like 10 options, then usually the first few options will be choose. Right, I'm going to pause the video here where I find an example that I will demonstrate now. Right, like I said, I will find one example to demonstrate what I'm talking about. We should scramble the answer. Right. Oh, here's one example. This is about this is one of a statewide special election in Orange County, California. So this is the recall governor back in 2003, right? So let's say if you comment in and you didn't know who you're going to vote for, and you have this many people, are you going to read through all of them? Answer is most likely not. So ideally, you want to know who you're going to vote for, and then you go there and look for the name and match that. It's just like the survey. If there are 10 options, and then you don't know what to choose, more likely you're not going to read all 10 of them. Right. And so just in case that this historic purpose, in this case, Arnold Schwarzenegger, he actually win. So this is on the rare occasion when the governor is being recalled and a new guy coming in. Right. So, like I said, if there's in the survey and there's 10 options, most of them, most likely, all 10 of them will not be read, and usually the first few options will be chosen. So in that case, you are trying to avoid those things. Or if we do, we try to scramble the 10 options in different forms, so that when people read them, they kind of more random, and it should be better. Right. And the other errors Another bias will come from the data entry errors. Of course, if you enter something wrong, so those things are easily fixed. Make sure be careful with the data, right? And this is just a summary whether we have non-sampling errors and sampling errors. Right. So the non-sampling errors are errors that result from sampling bias, non-response bias, response bias, or data entry error. And the sampling error result from using a sample to estimate information about the population. So when we don't choose the well sample, that will result in the sampling error. Right. So next we have the design of experiment. This is very long part of the section, and so I'll let you do the reading yourself. Just familiar with some of the terminology here. I'm not going to ask you the definition of those terminology on the test. Just some of them, just know what it is. Like in experiment, of course, something that we study, and then any combination of values of the factors to affect the result of the experiment is called treatment. For example, if you study the effectiveness of the vaccine of 10,000 people, 5,000 people will receive the vaccine. The other 5,000 people will have just water. And then after that, we conduct the result. So the treatment is the vaccine, right? So talking about that, we have the control group. Control group serve as the baseline that can be used to compare to the other treatment. So the baseline here is, let's say, in those the effectiveness of the vaccine again. Those 5,000 people who do not receive the actual vaccine, those are control group, and the other 5,000 will be the group that we test. All right. However, we cannot say, we cannot tell. Usually, we cannot say the person who have a vaccine or not when we do the study. We just either give them water or the vaccine, but we will not tell them what it actually is, because the feeling of the person may affect the result. For example, if you're going to test the effectiveness of the vaccine and you know for sure that you did not get the vaccine, you only have water, then you might have to be a little more carefully to go around, right? Whereas if you know that you're going to get the vaccine, then you're a little bit less careful. You can just go outside and meet other people, because even though it's still a study of the vaccine, but at least you know to get the vaccine, versus somebody knowing that they not get in the vaccine, they just get water. So the feeling, the knowing of the person may affect the result. So that's why the study or the experiment should be blinding. So this is the non-disclosed treatment of experiment of the unit is receiving. So the person that receiving nothing is called placebo. It's such like for the effectiveness, it's just like the sugar tablet that look and taste and smell like the actual medication. But actually, there's no medication in it. But the object, the people in the research, they do not know that. So that's called why it's called blinding. So either single blind is where the person who's got the test do not know about that, but the doctor will know about that. So that is single blind. And double blind is the people who, let's say, talk about the vaccine again, the people who take the vaccine and the people who administer that, we do not know who's will receive the real vaccine or not. So that is the double blind. Right, here's an example. As an English department of a community college is considering adopting online version of a freshman English course to compare this to the traditional course, which is the lecture. They will split randomly split a section of her course. Half of them will receive traditional course and the other half will be online. At the end of the semester, both groups will given a test to determine which perform better. Alright, so who are the experimental units? Well, that will be the freshman English students. What is the population for which study applied? Well, actually, those freshman English student and so the freshman English student will be the population, and then the experimental unit, that is whatever the section that is split, that is a section of it, just one section that is split, split. Right, so once again, the freshman English student, that should be the population, and who are experimental unit, only a section, that experiment. So what are the treatment? Well, the treatment is half online, half traditional, so will be half of them online. Online setting, online class, and what is the response variable? So at the end, we're given a test, so based on that test, we determine which class is better. Next, why can this experiment be conducted without blinding? Well, because when you tell the person you take the online class or not, that person knows exactly if he or she taking an online class or a lecture class, so they cannot be conducted blindly. Right, let's have the rest of the section. It's just reading, so I will let you do the reading rather than I go over that over the video, because I said all the time it's just reading. Right, but of course the focus on the chapter is whatever we have in the videos, the terminologies and the reading, just for you to know, so you know what it means. We don't have to precisely state what is the definition. But with that, I finished what I want to cover in chapter 1. Thank you for watching. See you in another video in statistics.